enable the Science Cloud, and without them we really wouldn't have a Science Cloud. So I see Garrison Vaughn and Laura Carrier from there. Let's see, Scott Sino is on the line as well, and that might be everybody from that group. And this is a recorded meeting, so just to let you know, we are recording this as well, and we'll make it available online afterwards. Okay. So I'm just going to go through a couple of updates to the Windows virtual machines and the Linux virtual machines. I'm going to review the digital globe search tools that Jim Shute demonstrated to us last webinar. And I'll tell you a little bit about data discovery. I'll review some of our environment structure and how to add products to the ABoVE Science Cloud. And then again, as I said, we'll have a time for questions. So updates to the Windows virtual machines. I'm not sure that everybody is using Guacamole to log into the virtual machines, but this is a really great way to log into the Windows virtual machines, and it's quite easy, and it opens up in a web browser. I've put the web address here, and it's a very nice way to get into the Science Cloud. I was going to just show you what it looks like. Let me see when you do log into that. So this is what it shows up as for me, but it's through, you log in through, I wonder if I can have more than one open at a time. Possibly not, we'll see. You come to this screen, you go to guacamole.nccs.nasa.gov, come in here, ADC, backslash your username, and then your password. I just have to hope that I get mine right, which I thought I might not do, which is why I logged in previously, so I didn't have to worry about it. And you come in here, you're logged into Guacamole, and this is your, a Windows virtual machine environment. You're on the Science Cloud when you're here, and I've popped up the PC window so you can see what data sets are already available to you when you log in here. You've got your C drive in case you needed to store something there, but really you should be storing something in your no backup space, which is already mounted onto the Windows machines here, no backup. You also have your home space available to you. This is the MERA data record. That's the Landsat data record here. So you can log in and find all of your data, or all of the public data that we have. This is the ABoVE gridded Landsat data, as well as the original ESPA data that we've made available. Damien Sulemanesh is the one who converted all of our Landsat data into the ABoVE grid. Additionally, we have this ATT pub repo. Here it's called AT Repo 01, but you could navigate down through here, and all of our communal data sets are available through here. So we have a number of ABoVE products that are in the Science Cloud here. And see, we also have a number of miscellaneous products that different groups have added to the Science Cloud, which are available. And we have a number of digital elevation model data sets that have been added to the Science Cloud and which will be added to the Science Cloud. So Matt McAnder, I see a note from you. Guacamole's crashing for you when you're trying to view orthoed NGA imagery. I would suggest putting in a ticket. I'll put the email here. You should do support@nccs.nasa.gov. And there could be something wrong with your instance of the Windows virtual machine. There are a number of different machines, and we can set them up so that you can have a different machine available to you. It could be something with your virtual machine if many people are trying to log into the same one. So I think the first thing to try for you is to set you up with a different Windows login. So like right now, for instance, I'm on GS6062 Win58, and I think they have a number of machines. We could try a different one, see if that helps you. See, Matt's still typing. We'll get his question when he's finished. So that's what I wanted to show you about the Windows virtual machines. You can see here you can open ArcMap. right here in the Science Cloud. You can go to any of the products and open them within ArcMap. They're all already here. You just have to click on the Add Data link, and then you can go to, I think it's all under this PC. You have all of the different drives here that I was showing you. Backup space, that's your personal space, Landsat, MERA, NGA, that's the digital globe imagery, and then our public repository is all here as well. So you can link to any of these spaces and open the data right up here. So if you're using a Mac at home and you want to be able to use a PC to look at your imagery, you can use a Science Cloud for that. So don't forget that that is an option. Yeah, Matt's asking, are other people able to successfully view and explore the ortho images in a GIS viewer via Guacamole? 10 plus ortho images at a time. I know that I've been able to use it to look at imagery. I've just used it to look at the NGA imagery itself, and I've been able to add that in without issue and open them up. But if others are having issues, please let us know, because we can't fix the problems if we don't know that they're there.
Hey Liz, this is Laura. Since Jim's off today, I'm just going to capture that question and forward it on to him, and maybe he can get back to.
Sure, get back to Matt. Okay, great.
Get back to Matt, yeah. So.
All right. Well, thanks for bringing that to our attention, Matt. Oh, I got to switch these displays again. There we go. All right. Okay. Updates to Linux VMs. This may have been mentioned in a previous webinar, but I just wanted to let people know again that we have a number of ABoVE nodes for use by ABoVE Science Cloud users. It's ABoVE 101 through 108 are now available. We previously just had ABoVE 101 to 104, and we have expanded that, and you can, when you're ready to run a process, you don't run it on your login node, either your DSC login node or your NGA login node. You would SSH, you type in SSH space, ABoVE 101 through 108, and there are more VMs now available on the Linux side, which can be used by ABoVE scientists. If you end up at a point where you're ready to run many processes on using the Science Cloud, at that point you can send an email to support or me or both of us, and we can set you up with your own set of virtual machines if you know that you're ready to really do an intense amount of processing. But if you're just trying to test a few things out and it's not that much, you can use these 101 to 108 nodes. Also, these nodes have been set up so that you can use Slurm on them, which is a job scheduler, and that's available too. And if you have questions about how to use that, you can contact support. Okay, I just wanted to put this slide in here. Jim Shute last month demoed these NGA data discovery apps. So if you're interested in these apps in more detail, you can view our presentation from last month, which is on our Science Cloud website. But we now have new tool web links for them. These are the final links. Last month we just previewed the development links. So if you want to, you do need to sign in. When I was doing this earlier today, I had to sign into the Science Cloud to be able to access these links. But I pulled one of them up. Let's see if my computer, there we go. That one is here. So they look like this NGA data discovery tool. So I've opened up mine within my Guacamole instance of a Windows virtual machine. And maybe I should go back out again so you can see what it looks like. You start out, and I've just zoomed in already to an area of Alaska. You can see Fairbanks here. You can do a spatial search, select a polygon. We'll select something rather small. and then search for the footprints that are available, the digital globe footprints available within that polygon. And this is the public version of this viewer, but then you can also log into the ArcGIS portal for a kind of a more in-depth version where you can actually see where these data are located on disk if you want to then go and grab these data and use them in any processes. So these are available, these web tools are available now, and I'd encourage you to check them out, although you do need to sign into, for instance, a Windows VM or Firefox on the Science Cloud in order to grab them. Although I think Jim is working on making them public as well, but I couldn't get on it today when I was trying from the public side. All right, let me pull back up my presentation. Display settings. Okay. So I showed you just the data discovery tool, but there is an advanced data discovery tool. And if you need a portal account created, you can send a ticket to support, and please use the subject line, new ArcGIS portal account request. All right, data discovery in the ABoVE Science Cloud. We've talked about this previously, but I wanted to bring it back up as we now have some data sets in the Science Cloud. We have a search tool that is accessible once you have logged into the Science Cloud. So you do need to log in first, and then you can get to this search tool. And it's a system-level tool to search for and locate data that we've staged here on the system. And I've given you the web link here, HTTP, and then it's Odyssey, 8080 Odysseys. And you'll want to sign into your Science Cloud account first, open up Firefox. You can do that from one of the login nodes, and then you need to type this in, and then you can pull it up. There's a video where you can see how to search in Odyssey, and I've got the link hot linked in here, so that'll be available after this call. And you can see a table of available products here, and I'll just, oh no, what are you doing? I'll show you what that table looks like. I think I've got that. Might not have that one open up anymore. Let me see. Here's what Odyssey looks like. So I'll clear this so we can go through it together. So it's called Odyssey. Get us up to the top of the page here. You can search for data through this search tool through this search scheme they have here. So to get to this Firefox, I first logged into my Science Cloud account here, and then from the login node, I typed in Firefox. And then when Firefox came in, then I typed in this Odyssey here. Right now, it's giving me a hard time. Well, we'll see. We'll see if it comes back up. My PowerPoint crashed too, so let me open that back up while we're waiting. All right. Well, we'll give that some time. We'll come back to that one. So we do have a table of available products, which is on the ADAPT site. Let me see if I can show you that. I wanted to show you guys this anyway. So there is a very nice ADAPT website. ADAPT is our platform that the ABoVE Science Cloud is running on. And there are a lot of useful resources here. They've recently updated this website. Ganglia shows you who is using the. I'm not gonna do that right now. If you need a Ganglia account, well, you can use your, I think it's your LDAP username and password to get into Ganglia. Laura,
yeah, you're correct. Okay. If you have an active account in Science Cloud, you're able to access the Ganglia resource using those same credentials.
And Ganglia is a way to look at how our resources are being used. It shows you how much is running on a given system and what nodes are open or what nodes are being used. So you can see if your processes are running well. If you have your own dedicated set of virtual machine nodes, then you can see if your data are processing the way you expected and if you're utilizing the system well. User access, you can see who can get access, how do I get access, capabilities, how to use Adapt. The one I was going to show you here was our ABoVE FAQ, which I don't know why that one's not. There we go. Okay. So what data are available in the GovScience Cloud? These are just PDF lists showing you what data are available. We've linked to this MERA and MERA2 reanalysis data, and so when you look at the list of data, including this MERA data, the list is very, very long, so it's a very large PDF and it's hard to look through. So we split it out. So this is just above Science Cloud data sets, not including the MERA data sets. And you can look through and you can see the name of the product and the description for what data we currently have in the Science Cloud. And as you can see, you don't need to look at all these now, but we're starting to grow our data sets, and more data are continuing to come into the Science Cloud. We're also working to add in the airborne data, so that's something we're actively working on right now. All of the foundational instruments which collected data over the summer, the L-band radar, P-band radar, the ELVIS, and the AVARIS data will all be staged in the Science Cloud. We're working with the Oak Ridge DAC now to figure out how to get data from their portal and setup of data to the Science Cloud, and we will then work on how to make metadata from those products available to users in Odyssey and be able to show you what data we have in the Science Cloud. So I think over the next month or two we'll have more to say about that, but we are working actively to get the airborne data in the Science Cloud. Okay, let me go back to my slideshow, swap my views. There we go. I've kind of mentioned this a little bit, but I'd just like to go over it because sometimes we have new people on this webinar. And so in ATT Pub Repo on the Science Cloud is where we have all of these different data sets stored. So you can use Odyssey to look at where the data are, and then you can go to these different areas of Pub Repo to really better understand where all the data are. MISC products is useful products for science team members, but they have not been created by science team members, whereas ABoVE products are products that have been specifically generated based on an ABoVE project. DEM, we have a lot of digital elevation model data that we are trying to stage in the Science Cloud, and I'll just show you that. This is when I log into the Science Cloud, I use MOBA Xterm, and so you kind of click on the DEM link, and you can see not all of these have a full suite of data in them yet. For example, the Arctic DEM is as yet unpopulated, but we are working to get Arctic DEM data in here as well. But we have a number of different DEM data sets, and some of them have already been generated in ABoVE tiles. So this is the Alaska National Elevation Data Set and the Canadian Digital Elevation Model. And they are available here in our ABoVE grid and projection. So it's easy to use these data anywhere within our ABoVE domain. Let me see if that, there we go. So this is, let me jump back to Odyssey, and I'll show you where you could find this digital elevation model data in Odyssey. So if you've gone to your Odyssey search system, and you can go to digital elevation data, and you can click on the different variables. We have this Alaska IFSAR data, and it shows you where the data is located. We also have this digital elevation model data for Alaska, for Canada, And for from Paul Montesano and Chris and I have also created a set of digital surface models from digital globe data in various parts around the globe, and so that is also available in there. And then we also have this Aster GDEM product. Oh, that's going kind of slow today. We also have this Aster GDEM data, which is a global digital elevation model data set. So all of these are currently available in our Science Cloud, and we continue to add more data as we can. I see we got a question, a few questions here. So, should have checked this earlier, but we had a couple questions going back to some of the other topics I touched on. Adriana Foster asked, is there a job limit for SLRM jobs? And Scott replied that there's no current time restriction on SLRM, but we can adjust it if we need to. And then another question was, can you only open the NGA data discovery tool on the Windows VM? You can open it not just from the Windows VM. You could also open it from inside the Linux VM if you log in, for example, through MobaXterm or another terminal, and type in Firefox, and you can open up, a Firefox window like this, and you can type in the long web link for the data discovery tool, and then you could bring it up there. I know that we're working to make it public as well, but when I tried to do it here earlier today, I couldn't do that. I'll have to check in with Jim Shute and make sure I understand where these tools are going to be available. But right now, I know if you log into the Science Cloud first and then use a browser from inside the Science Cloud, you can access the tools. Okay, let's go back to our project. Okay. So I showed you where to find data sets and how to find data sets using Odyssey, but I also wanted to just talk a little bit about where your data sets should go. So in the Science Cloud, you as a PI or as a Science Cloud user, you can keep your unfinished products in your no backup space, and then when you have finished them, we can put them into our shared directory space in PubRepo. And we have had investigators do that. There's Eric Staffrahan from the modeling project has recently put a lot of data into PubRepo, and we have some other products that people have generated on the Science Cloud and then moved them over to PubRepo when they were finished with them in their personal directories. When you're ready to move your product out of your space to the ABoVE product space, you can let us know and we can help you move it over. Then we'll have some metadata that we would need from you. And I have a metadata sheet that I can send to you when you're ready to move your product over into our public space, or even if you just have a product that you're interested in using on the Science Cloud. We just have a pretty minimal metadata. It's not many fields that we have you fill out. And you send it back in, we get it in the metadata, and we get it into the PubRepo, and then it's there for you and everyone else to use. I think those were most of what I wanted to say as part of our formal webinar. The only other announcement is when you're using the ABoVE Science Cloud and then you want to use data you've processed on the Science Cloud in your publication, please make sure to cite the Science Cloud, and I've given you some text here on how you can cite it, or just basically you're just citing the NASA High-End Computing Program. So go ahead and please do that as you do your publication so we can make sure we are capturing use of the Science Cloud in publications. This is making me think of one other note, which is that we recently had a project approved on Discover, on the Discover supercomputer to process the ABoVE DEM. So there's the Arctic DEM, which is for areas north of 60 that is being produced by the Polar Geospatial Center, and they're doing it on the NSF Blue Water supercomputer. But south of 60, we have our own separate ABoVE project to create digital elevation models for that area using the same processing stream that Polar Geospatial Center is using for the Arctic Dam. So it will eventually be a seamless product for ABoVE users. We'll have it stored in the Arctic Dam space on the Science Cloud. And but as part of that Discover project that we started last year and we just recently renewed, we asked for additional processing space in case ABoVE users need to eventually use Discover, or if we asked for some seed space so that we could allow ABoVE investigators time on Discover to consider if they needed to use that system and the parallelization that it offers for their processing. So then that project was approved. So if you are using ADAPT but you feel that your project is better suited to Discover, we have a space where you can test out some of that and give it a try and see if it really works for you. So you can contact me if you're interested in that at all, and I can work with you on that. It's not a lot of space, but we have 2 ABoVE investigators right now that are part of this project, a part of our Discover project, and are trying out their code on Discover. And this is cases where they first tried it out on ADAPT and needed more processing than we had, and so they've moved over to Discover. So feel free to contact me about any Discover processing needs you might have to, or you can submit a ticket to support. So I think those are the main notes that I had for our meeting today. It's right at 1:30, so we've got a half an hour left. We don't always use our full time, but if you have questions about anything I presented today, or just general questions about the Science Cloud or logging on or anything like that, feel free to ask them. Also, if any of our colleagues at NCCS have any additional announcements that I've forgotten to mention, please feel free to go ahead and chime in now too. Everyone's so quiet. Or if you just want to jump in and tell us how you're using the Science Cloud, I'm always looking for users to tell us what they're doing, and we can even feature you at a future Science Cloud webinar if you're interested in talking about the type of processing you're using on the Science Cloud or how it's going for you. You can either chime in now or send me an email afterwards, and if you have a success story on the Science Cloud that you'd like to share, we'd be more than happy to feature you in one of our Science Cloud webinars where you can just send a couple slides saying, this was my problem and this is how I use the Science Cloud to implement it, and here's what I'd like to, here's how I plan to finish my project. All right, Mark Topping has said, can you keep the earlier webinars online? They are very useful. Yes, we have the webinars online. Oh, and P.S. our ABoVE project has an opening for a PhD student. So Mark Chopping is one of our ABoVE investigators, and we'll allow it. He can put a little plug in for an opening for a PhD student. So if you're interested, contact Mark Chopping. He's doing he's doing some work on I guess what would you call it, Mark? Shrub and tundra and tree issues? You can type in your title. Well, while he's typing, oh yes, shrub mapping, identification of change using high-resolution imagery. So that interests you, or you know someone that's interested in that topic, and you have a PhD student someone you know who's looking to become a PhD student, please contact Mark Chopping for that. Does anyone else have questions? It's a quiet bunch. I see some new faces too. Are some of you from the Animals on the Move project? I know I had initially told some of the Animals on the Move group to call in and learn more about the Science Cloud today. So if you have questions or want to talk through any of the processing you're interested in doing, please just let me know.
Hey, Liz, this is Eric Stofferon.
Hi, Eric.
Hey, I was just wondering if there was like a preferred method with which you could determine which of the Linux above nodes were appropriate for running a particular, essentially which node is being used the most and which one is kind of the most open at any given time.
Most users I see nowadays are using Slurm for job control and invocation. The sinfo command will tell you a little bit about ongoing jobs and what nodes are and aren't allocated.
Cool. Yeah, that sounds great.
Roger. Yeah, and certainly, if there's congestion within Slurm or we're seeing congestion for resources, we can tune Slurm as needed, or more likely just grow the scope of above nodes. We do have some spare hardware capacity to grow to meet demand if and when we see it, or if you know you're going to have a burst demand case, feel free to let us know in advance as well, and we'll try to accommodate that.
Sounds good. I usually don't for my purposes, but it is nice to not have to go to a congested node if that's possible.
True that.
All right, thanks.
All right. Well, any other questions? You guys are a quiet bunch today. So our next scheduled webinar would be November 17th from 1 to 2 p.m. Eastern. And we are still here, so if you do end up with a question and you didn't say it today, you can reach me, elizabeth.hoy@nasa.gov, or you can feel free to send a ticket, support@nccs.nasa.gov. And I look forward to talking with you on the November 17th. Thanks, everybody.
Thank you.